Okay, so today we're talking about bounded area. So the last 2 days we've been talking about area between two curves. Today we're going to be talking about bounded area, which is basically the same thing. When we talk about area between two curves, we're usually talking about how where two curves intersect, creating an area, and that area is bounded by those two curves. But there's also area that we deal with when that area itself is bounded by more than two functions. Okay, so this is bounded area, but not between just two curves, but we actually have more than that. Okay, so one of the things that I tell my kids is draw a picture. It really does help. So y equals 6. So 1, 2, 3, 4, 5, 6. So y equals 6 is this horizontal line. Then we have x equals 1, which is a vertical line here, and x equals -2, which is a vertical line there. Okay. And then we have our last function, which is the quadratic, okay, where the vertex is at 0, +2. It opens down. It's been vertically stretched by 2. So 1, 2, 3, 4, 5, 6, 7, 8. And then here. So this is my quadratic, something like this. Okay? And this side hits here. So basically, we're finding this area that's created from these four functions. So basically, this area here is what we're talking about. So this area right in here. Okay? So if I'm looking at this area right here, and I need to find this, I'm still going to be using that area between curves equation. So I've got to decide, do I do vertical or horizontal strips? So if I draw one here, I hit these two, that's fine. But over here, I'm going to have to break it up, and I'm going to have to do multiple integrations. And I don't want to do that if I don't have to. So really, it doesn't look like we're doing horizontal ones. Okay? So, but if I do vertical ones like this, it doesn't matter where I draw my strip, I'm going to be hitting this function, the y equals 6, and my quadratic all the way through. Okay, so since I'm using vertical strips, I'm using this equation. Function top minus function bottom dx. And this function is my top function, and the quadratic is my bottom function. So basically those other two, the x equals -2 and the x equals 1, those are what's causing my area to start and stop. Because if I move either one of these vertical lines over, my area gets bigger. So what those two equations are basically my a to b. So it's -2 to 1, and it's my function on top, which is y equals 6, minus my function on bottom, which is -2x squared plus 2 dx. And now that we have the setup, it's basically just a definite integral problem at this point. So let's simplify. So when we distribute our negative in, we're going to get, this is -2 to 1, we're going to get 2x squared. That's going to be -2, so 6 minus 2 is +4 dx. Okay? And now we take the antiderivative. So add 1 to the power divided by the power. So we get 2/3 x cubed plus 4x. And we evaluate it from -2 to 1. So we plug in our top one function first. So 2/3 times 1 cubed plus 4 times 1 minus the bottom, which would be 2/3 times -8 plus 4 times -2. So this is 2/3 plus 4, and then this would be -16/3, which would be plus 16/3, and then -2 times 4 is -8, which just makes it +8. So 18/3 plus 12, 18/3 is 6, so 6 plus 12, which is 18. And that is my area. Okay, so basically this problem is nothing more than what we've been doing. The only difference is that we have more functions to draw when we find our bounded area. And then we set up our equation using this, and then we just do a definite integral. We simplify and integrate. So really not much has changed in what we're doing.